Hey, how's it going, guys? My name's Daniel, aka HashLips, and welcome back to the continuation of the Solidity Basics tutorial. You will immediately hear that the sound quality is a lot better in this video, and that's because I got a microphone. Carrying on where we left off last time, we declared these two addresses. Now, the proper way of declaring an address is to actually typecast it first. So you have to write address in the front and then typecast this address to make sure that it's valid for what we're assigning it to. This just helps the compiler realize that this is an address and allow you to perform special functions on it, seeing that we are casting it into this type. Castings can happen with numerous things. We can typecast different variables into different values if we really wanted to. For instance, let's say we wanted to use this myInt8 value, but we want to typecast it into an int 256. We can define an int 256 over there, and we're going to call it new. Let's call it my new variable, right? And that's going to be equal to my int8. Now you'll see that this can automatically work because this is actually less than the integer itself. But the proper way of doing it is to actually cast it into the int 256 and then assign it. This will make sure that the values and the types, underlying types, are the same and that it works correctly. That's just a basic example, but we'll get to casting a bit more in the future. The reason why I want to just explain to you the casting of the address type is because it's very important to work with it. I'm gonna for a second just change this also to public, and it really doesn't even have to be public, so we can just maybe take this out for now. But basically what you want to do is experiment on how these addresses work. Addresses is a special type and have extra things attached to it. For instance, we can actually see on my address, my contract address, we can see the balance if we go and say .balance. Alright, this statement over here will actually assign the balance of this address to something. We have to assign it if we want to use it. So we can maybe say uint 256 is going to be equal to my contract balance, like so. The compiler will moan and say, because we don't have a name, so we can say balance of my contract, like so. Now, when we have this in this variable, it will have stored this address balance, and that is what we want, right? That's perfectly cool. Address is a very special type as well. If you want to improve the type, and if you want to start sending money to this address, you have to make it of type Payable. How do we do that? We can basically say that this is address, but it's also of type Payable. This will allow us to define the address and make sure that we actually allow it to accept money, okay? So let's see how that would work. We can just see what it's saying, and it's saying that convertible expected type of Payable. So if we want to use this, we need to convert and typecast this address into a Payable address. If we do that, we actually get some extra functionality on my contract address. We get the transfer function where we can transfer some money to someone, right? And that is pretty cool. I just wanted you guys to understand that you have these special types in Solidity, which we'll get to more in detail, but this is a brief example of it. Now, I'm going to leave this just like this, but what I want to do is just show you another special thing in Solidity called this. Whenever we refer to this, we refer to this actual contract's address. Now, obviously, we don't want to make this payable, so we will say this is just a normal address and take off the payable there. The this keyword will actually convert this address's, this contract's address, its current address, and refer to it as an address, and you can call its balance, which, like I mentioned before, an address, even if it's a smart contract, can have value. It can have a balance of ether. And that's just the concept that I want to convey before we carry on to the next step. Okay, so now what you want to do is create yourself this my variables file along with the my variables smart contract, and then add the necessary license, the pragma line, and create your empty smart contract. We are going to now have a look at how it works with variables when we talk about the different variable families. I talk about families because that's how I associate it with. So, like before, if we declare a UN256 and we call it number, we can assign this number a number like 20, and this will be considered as a state variable. Why is that? Well, any of these variables that's being declared on the, how can I say, inside the immediate box of this smart contract, something that's going to live on the blockchain forever. So we can maybe have a uint, we can have a bool, and we can say maybe this is paused if we want to pause a smart contract. So we need to say that as true, whatever it is. These are considered as state variables. Why is it considered as state? Like I mentioned, these live forever on the blockchain. These are things that when you deploy your smart contract, these variables actually sit and live on the blockchain as bytecode, and that the computer can interact with, and also that the virtual machine can update and change state. How do we change state variables? We usually do it through functions. But functions can also have their own variables declared inside them. Let's look at a simple example. We can create a function by saying function myfunc. We can put the brackets, make it public. You have to specify the kind of who can access, the access level of it. That's why we put public there. But we can also declare the same two variables in here. Now, if we look at the warning sign, we can see that these declarations already have the same name, and that's not going to work. You can't have the same name because it's going to get confused on which one to use. So what we can do is append local just for this explanation. Obviously you can give it better names, but this is our local variable. So this is the local paused, and that's the local number. Now you can see that these are considered as local variables. And why is that? The reason why these are called local is because they only live in this space of this function, in the execution of their function. That's why I associate variables as living and breathing little things. A variable is simply a space in memory that's allocated for this variable to live in. Now, when you get to the state variables, they live forever with the smart contract. That's why people building out wallets can put the amount of people in here who own some of this coin, or the NFTs count can live in there because it will never die. If you work with functions and the variables that you declare in a function, they can die, and they can actually, they actually are just here in memory before they pass away, if I can put it like that, before they expire, and the virtual machine gets rid of it in memory because the function already ran its course. As long as you understand that we get local variables that can expire after a function execution and is only saved in the duration of the memory that it's needed, and state variables, which is actually saved forever on the blockchain, you are fine with this concept. The last thing that you can look at is global variables. We can look at global variables next. Looking at global variables, we can see that we have these objects, block and message. These are the two most important global variables that you'll be using in Solidity. The reason for that is because our smart contract itself has access to these global variables because these global variables is on the blockchain itself. Let me explain this in an example. If we go back to our code, we can actually call a global variable and assign it to something. We can go and assign uint 256. We can give it a time. Let's go and say this is our time. And how do we get the time off the blockchain? Well, we got this extra big global variable called block, and we can say this is the time stamp. And once we've declared that, we are actually making use of a global variable. But keep in mind that we are saving this now as a state variable, the current time in this particular instance. But I am going to say this is a state variable saving a global variable. All right, and that's basically what it is. It's a state variable that has access to the global variable that we have now saved in here. We get different variables such as message, like I said, and message we usually have access to in functions. See message as the transaction that just came through. Someone just called the myFunction function on our smart contract, and with that, it passes through a message object. Now, when that happens, it's automatically inside of this function, so we don't have to kind of pass it through as parameters. We can simply assign it. We can assign an address and say the sender address. So we can say this is going to be the sender's address, and we can set it true to the message.sender. And this is perfectly valid because the message.sender will live inside this function, or the function will at least know about this based on the transaction that currently took place. It's not specific to the function, but more a global variable. If we wanted to get access to the actual value that someone sent along with the transaction, we can get access to that by typing in msg message.value. This will hold the current value in way that the person sent along, and then we can do calculations with it. That being said, I hope you have a clear understanding that there is two types of variables that we work with in Solidity: variables that's saved in memory and variables that's in state, that's forever on the blockchain, that's sitting directly in our smart contract. We also have access to the blockchain global variable and the message global variable, and there's a few more that we have access to. So feel free to go and read up on this article, and you'll have much more insight on how it works and all the extra things that you want to do and use. It's always important to go through these tutorials, have a look at the documentation, because the documentation really explains it very well. The next things that I actually want to have a look at is looking at the actual accessibility of functions and variables. So it might be confusing a little bit hearing me talk about scope, state variables, local variables, global variables, where can one access the other ones, and it sounds all a little bit intertwined. And that's because it kind of is intertwined, but we have to understand it in a little bit of a separated way. When I talk about scope and basically where variables live, I talk about how can they be accessed by the components around them. For example, if we declare a function, this could be thought of as a closed box. The outside world, which is this little smart contract and everything that's existing between this bracket and this bracket, will not really know about the variables that we declare inside a function. Inside here, it's local variables, local to this function. But this function can have access to the variables that's declared here on the state variables. It also has access to the global variables like I explained, as well as its own local variables. It basically goes in a parent-child relationship where the child always has access to the parent's information and variables, but the parent does not necessarily always have access to the stuff inside a function unless it's being returned. So that's basically the difference of accessibility and how scope runs and where it starts and where it ends. There's a lot of articles on scope, and it is sometimes much better just to dive into the tutorials and start coding along. You'll quickly find out where variables can be accessed or not, and usually the errors will let you know if it's a scope error or if it can't be found or what the issue might be. The reason why we can't refer to this number and give it the same variable name is because it will confuse the program here in the function to know which one it should select. You can get around this by using a this keyword and then maybe passing it through, but I don't want to confuse you guys too much with that. I just want to explain the basics of Solidity in this course. Now that we understand that there is a level of accessibility, let's look at inheritance and how other smart contracts can now start using variables that's in this smart contract. What I'm going to do is I'm going to duplicate this contract and I'm going to put it over here. I'm going to call this contract, let's call it something interesting. Let's say I need variables. I think that's a cool and interesting name, and the reason for that is because we are not going to pass a single variable in here. And what I want to explicitly explain here quickly to you guys is that when we deploy our smart contract, I want us to see how this smart contract will actually have access to the underlying variables over here. How can we do that? Well, we use a method and a way called inheritance. We want this smart contract over here, which is totally separate. Remember, this is a box and this is a box. They do not know about each other at this stage. If we want to use the stuff inside of the smart contract, we can inherit from it. We don't necessarily have to always use it like this. If we just want to call the smart contract, there's a different way of calling functions on a smart contract. But if we actually want to make this smart contract the same as this one, having all the capabilities and more, we inherit from it. So we basically say that I need variables contract is of type my variables. And as soon as we do that, automatically this smart contract has the underlying function, my func, and these three state variables inside of it. Now, I see that there are a bit of warning signs over here, and basically it says that there's a bunch of unused variables. Now, we can also add a view in this function, and the reason why is because we are not changing any of the state variables with my function. We are simply viewing random variables, right? So in order for this not to complain and I don't want to use them, I'm going to comment this out just for the time being so that we can run the program. So we're not using these variables, and Solidity really wants us to make use of their variables. We're just going to comment that out for now. Next, what I want you to pay attention to is if we now go to the deploy section and we go down here, we can close down all our previous deployments and we can see that there's a I need variables contract. We also have our my variables contract. Now, if we deploy the my variables contract, which is this one, we can deploy it and we can see that we only have access to the my function and it does nothing. Okay, it's just a call function and it has no functionality. But it is there for us to call because it's public. Like I explained, if you make something public, such as this number, we can say save, and we can go in here, close it, deploy it, or close it, select the my variables, deploy it again, and we will have access to two things now. We will have access to the number as well as our function, which is public. So there is the number, it's 20, and the function still doesn't do anything. But that is important to see how it works accessibility wise to the outside world, and also to see that by inheriting from my variables, if I close this now and I write a variable in here, and let's call it UN256, we call it the awesome var, so var for variable, and we are going to assign this a value of 100. We are also going to make this public. What I want you to understand is that because we are saying that this contract is using this, is inheriting from this contract, we would basically get this public variable, this public function, and our own public awesome variable. So like before, if I just deploy this one now, we will see that it only has those two. But if I deploy the I need variables contract, which is inheriting from this one, if I deploy that one, you can see that there's three. There's the awesome variable, there's the number from this smart contract, and there's my function. It's important to know that you are not deploying these two contracts separately. This is not a separate instance, and that's what we are using here. It is actually this smart contract merging with this smart contract and giving all of its parameters, its functions, its state variables to this one, because it is of type this one. It's almost like saying this is of type car, and this is now a famous car brand, and because it's of a type car, a car has doors, wheels, a steering wheel, so defining what this should be and then merging everything so we can use it. So we only deploy one smart contract, which is this one, but it's inheriting from this one and having all its features. So now is the point where we can actually dive into the accessibility of when you go and inherit from another smart contract that gives over all its functionality. Let's say we had a private variable inside of this smart contract called paused. If we declare something private, this smart contract, even though it's inheriting from it, will not have access to the paused variable. That is because in some cases you want your logic to work in a way where it's not accessible and has internal logic that you don't want to share with the rest of the smart contracts that's inheriting from it. Just a disclaimer, this is not the same as interacting with different smart contracts on the blockchain. This is if you're physically trying to make this code a part of this contract. Okay, this is like saying I want to adopt all your features and use you and then go and deploy on the blockchain, okay? But anyway, as long as you understand that this variable can now not be accessed in here, this is perfectly fine. But what's very cool is that because our number is public, and let's make this time internal, we can use the internal and the public variables. Now let's see how we can do that. I'm going to declare another bool, and I'm going to show you this now that it doesn't work with private, but I'm going to create a bool and call this bool public. I'm going to call this paused, and I'm going to say false. You will see that this is perfectly valid because it doesn't have an underlying paused. This one is private, so it doesn't clash and it can't see it as the same one. But as soon as we make this public, then we'll have an issue. Because now it's saying that this is public, meaning you already have a paused variable name, and that is an issue. So that's how I can explain that a bit better to you guys. We can now go ahead and make use of the internal function as well. Let's go and expose the internal function to the outside world. We're going to make this a uint 256, and we are going to say this is going to be publicly accessible, but we want to expose the internal time that comes from this smart contract basically. So we're going to say that our time is going to be equal to the time. And it's important to know that this time is this variable. Just to make it a bit more clear, I'm going to say the time. So the time is our new variable, and we are saying it's equal to this variable. All right. So in the internal case where you declare something as internal, internal can only be used by the contract itself, its own box, and on other smart contracts that inherit from this smart contract. Okay, that's how you can make use of internal declared variables in a very safe way if you don't want to make them public. But to illustrate our concept, I'm anyway going to declare this as public and then show you how it looks. So if we save that and we deploy this again, we can see now that we have the time, and the time is indeed a timestamp that was recorded from this global variable. I hope this made a little bit more sense. There is some kind of nuances that you do need to take in consideration when working with global scope and all these access fields. You can read more up on it if you go and look at the types and also the global variables and the units and all these things. You'll find out that there is a lot of extra things that we can consider when looking and reading through Solidity code. But what I'm showing you now is literally the only thing that you need, and the only advice and knowledge that you need to carry on and do amazing smart contracts. There's a lot of things in Solidity that you can learn, which I feel that you don't need to know now as a beginner. Cool. So carrying on, we need to now just wrap this up quickly and just discuss the three different ones. Public, anything declared publicly, whether it's a function or a variable, can be accessed by the user outside of your smart contract, by any other smart contract that refers to the other smart contract, by a smart contract that instantiates another smart contract that I haven't shown here now, but it can have access to it, as well as the smart contract itself can have access. Private, only the smart contract itself can have access to this variable. It can't give access to the users, it can't give access to contracts that inherit from it. It's its own private variable. And variables are private by nature, I believe. I think so. Then we get lastly the internal. Internal is there to protect your variables from the outside user, so it's not public, but it can still be used by its own smart contract as well as other smart contracts that inherit from this one. I hope that is clear and that the variable scope has been described to you guys in a way where you know now that we have different states where variables get saved in memory on the blockchain, where we have the local variables, and I'm going to now uncomment this just to have everything in one for you guys. But that you have local state variables, you have global variables, and that you have different access levels. And access levels can be declared on each different level. So we can even say that this is public, but it won't make sense to make this public at all. That's why it will give us an error, because there's no need to make this public. Okay. But anyway, that being said, we can now just go ahead and continue with our journey. The next thing I want to explain is operators. Now, what are operators? And we have briefly seen it when we went to the Solidity smart coding documentation. We looked at operators when we looked at types. So when we go to types, we saw this list of these weird symbols, and you might think that this is something you'll never wrap your head around. Well, you are wrong, and I'm going to show you how to use it, and I'm going to show the basics of it so you understand completely. So that's the next thing we're going to look at, so stay tuned for the next video.